I want to look at a few examples here with regards to an imaginary number. And again, a reminder is that the square root of -1 equals I. And on slide 16, there's an example, and it's simplify the square root of -52. And not only will this be a good review for imaginaries, or not review for imaginaries, but it'll be a review for taking the square root, which was back there again in our first unit in Adventum. I do this radically different than the program. The program seemed to do a lot more work than it needed to do when it came to simplifying the square root of -52. And again, an imaginary number happens when we've got a negative, when we're taking the square root of a negative number. So let's start with the square root of -1 times the square root of 52. And the thing is, just right there at the top of the page, you can still see it on my notebook paper. The square root of -1 is I. So this problem is really I times the square root of 52. Again, if you like the way the program does this, it's fine. This is how I work out this problem. And 52 is 4 times 13. And 4 is 2 times 2, and I'm going to carry down the 13. When we take the square root of something, what we're looking for is we're looking for 2 of the same value to take out 1. So we have 2 2's here. We're going to take it out. We're going to take out the 2 because we had 2 of them. We already had an I out there, which it appears I forgot to write down. This is going to be 2I times the square root of 13. Let's look at another one. This actually is on slide 17, and it is the square root of -27. Once again, when we look at something like this, because we're taking the square root of a negative number, we've got to deal with that negative number first. -1 multiplied by 27 is -27. And the square root of -1 is I. And now we've got the 27. By the way, you really, really, really need to take out that square root of -1 first. 27 is 9 times 3. We can keep breaking that down. It's 3 times 3 times 3. And once again, when we're taking the square root, what we're looking for is we're looking for 2 of the same value. 2 of the same value. We've got 2 3's. We're going to pull out a 3. And then we've got the square root of 3. So the square root of -27 is the same value as 3i square root of 3. On slide 20, which are slides that you are supposed to work out, I want to look at this problem. Square root of 64 plus the square root of -144. Well, you can use Desmos or you can use your calculator to figure out, well, what is the square root of 64? It's 8. But over here with the square root of -144, once again, when we simplify this, we need to deal with the square root of -1 first. So as we deal with that here, the square root of -1, so it's going to be 8 plus I something, because the square root of -1 is I. And the nice thing is, on the square root of 144, we can take the square root of 144. It happens to be 12. So we get 8 plus 12i. It's all a matter, and you can see it, all a matter of simplifying these square roots, but we have to realize that the square root of -1 is I, and you have to take that out first. There's one more screen on page 20, on slide 20 here, that's got a problem which it says simplify. And as we take a look at this one, we get 4 plus 16 minus 20, all divided by 2. Got to be able to see it. Well, 16 minus 20 is -4. And once again, what we need to simplify here is we need to simplify the square root of -4. Well, this is the square root of -1 times the square root of 4. And the square root of -1 is I. The square root of 4 is 2. So this becomes 4 plus 2I. Again, we got the I from the square root of -1, the 2 from the square root of 4, divided by 2. Got to be able to see it. But once again, and not once again, but what can happen here on this particular problem is we can simplify this. This means 4 divided by 2 plus 2I divided by 2. And we can, because these are all even numbers, 4 and 2 and 2, we can divide 4 divided by 2, which is 2. 2I divided by 2 is I. If you want to get technical, it's 1I, but if you have to write the answer down like 2 plus I in this program, they don't like the 1 very well. They're probably going to mark it wrong. But lastly, on this video, what this is this is a complex number. It has a real number part and an imaginary number part. And I haven't worked through section 5.3 yet, but I'm guessing that it's going to get to the point where we're going to be using the quadratic formula and getting complex numbers for answers.